Worksheet 5, quantitative acceleration problems. This is an example of how to do these. They all start with a description of motion, and then there's instructions about how to show a solution for quantities that are unknown. A poorly tuned car accelerates from rest to a speed of 28 meters per second in 20 seconds. First, we'll make a well-labeled diagram of the situation. And that just means showing the object as a particle, a dot. And we think about motion, time is relevant, and there's a start time, and there's an end time. There's a starting position, and there's a final position. There's a starting velocity, there's a final velocity, and for all of the motion we're considering, there is a constant acceleration that occurs. In this case, the car doesn't tell us where it starts. We'll make our life easy and make that 0. It doesn't say explicitly a starting velocity, but it says from rest, and we know that means 0 velocity at time equals 0. Final time, that's that information right there. This is 20 seconds of motion. We don't know the position it's at. That's not up there. But the velocity, we see a speed of 28 meters per second. It's up to us to decide what direction it's going in. Let's make our life easy, say it's positive. So we have a velocity of a positive 28 meters per second. So we have a well-labeled diagram. Now we want a well-labeled graphical representation. That's what the velocity time graph is for. So I'm looking for velocity and time data. At that time, I have that velocity. So I'll have to scale my graph. Let me do that. So I made my time axis go to 20 and my position axis go to 40 because it's a 10 by 10 grid. And so I have 0 time, 0 velocity, and a time of 20 seconds, a velocity of 28 meters per second. So those are my 2 points. Because this is uniform acceleration, I can connect these 2 points with a straight line. That's the assumption I'm making. And I can work with this graph now to answer, find out what we don't know. First of all, we want to find average acceleration. You should know by now that the calculated acceleration, it's the slope of a velocity time graph, which is to say it's the ratio of velocity change to time change. The 2 easy points here, the change in velocity goes from 0 to 28 meters per second, and the time that takes is 20 seconds. And if I do the math there, that comes out to be 1.4 meters per second change every 1 second, which equals 1.4 meters per second squared for acceleration. And lastly says, how far does it travel in this time? How far should make you think of how displacement and the area of this graph. That will answer that question. So we have enough information to calculate that. It's going to be height times base, or 28 meters per second times 20 seconds. Divide by 2 because it's a triangle. Right, this area right here. And that's going to turn out to be 280 meters is how far it went. So there's an example of how to do these problems. Follow the instructions and work to a similar level of detail.